Okay, cotangent. Let's first recall what the original cotangent looked like. So the tangent, just roughly, okay, I'm not going to draw a perfect picture here. Tangent looks like this. The cotangent, okay, wherever it's 0, it's going to be asymptote now. So there'll be another 0 here. And wherever it's approaching 0, it's going to be approaching infinity. This is approaching the positive infinity, so it's going to approach 0. Okay, and then the tangent graph looks like this. So this is going to do this. So it's the blue. This right here is y is equal to cotangent of x. Now this is this graph with some transformation. Okay, so let's actually factor out this 3 first. Okay, don't forget to do that. A lot of students forget to do that. Then we get this. So that means we're going to have a vertical stretch. Okay, there's no amplitude. Vertical stretch by a factor of 2. The period, normally it's pi, now it's pi over 3. And the phase shift is pi over minus pi over 6. Okay, so let's set this up. A phase shift of minus pi over 6. So we're going to be at minus pi over 6. The period is pi over 3, so we're actually going to finish at pi over 6. 2 pi over 6 is pi over 3. So the quarter points are going to be pi over 12 and minus pi over 12. Okay. Here's the asymptotes. Y-axis. Now, normally, a tangent graph, okay, when you're at the quarter point, we're going to be at 1. But because of the 2, we're going to be at 2. Right? It's been vertically stretched by a factor of 2. So at pi over 12, we're going to be at negative 2 instead. It's hard to show the vertical stretch with tangent and cotangent graphs. I mean, if I had to draw the cotangent without the 2, it would look something more like this. Okay, just as a comparison. It looks very similar, right? Just more, it's sharper graph vertically.